Sustainability, Energy and Climate. Today we are having Professor Ajit Kumar Kolar Garu. He's a retired professor. We welcome you, sir. I would like to introduce Sir. Professor Ajit Kumar Kolar is a retired professor in Department of Mechanical Engineering, IIT Madras, founder of IIT Madras Energy Forum, and member of the Coal and Energy Committee of the Technology Information, Forecasting and Assessment Council, TIFAC, an autonomous body under DST. Sir had held many responsibilities like chief coordinator, a number of workshops, seminars, and international conferences on energy. Also, Sir was a resource person, outcome-based education since 2011. Chairman, Center for Continuing Education, IITM 2008 to 2014. Creator, IITM Heritage Center in 2006. Cultural Advisor, IITM 1992 to 1996. Sir's research area was heat transfer and energy systems, fluidized bed heat transfer and combustion, advanced coal technologies, PFBC gasification, CO2 capture, fuel cells, biomass combustion and gasification, life cycle analysis based sustainability analysis of energy systems. Sir has authored a book entitled Advanced Coal Technologies for Power Generation in India, NIAS report, and about 100 research publications. Under Sir's guidance, there are 18 PhD and MS scholars are there. And we welcome you, sir. I request you to take over the session from.
Thank you very much, Dr. Anusha, for those kind words of introduction.
Thank you.
I also want to add to that, because that would give some authenticity to what I am talking about. I was a scientist delegate to the Paris Climate Summit in 2015, representing the TIFAC DST as a scientist, where I was asked to talk about importance of coal technologies for India for a long time. So that, in fact, I consider it as a big kind of honor from the government of India to me, attending this important climate summit. Today, in all environmental climate change discussions, this COP21 Paris Accord is always quoted. Of course, I was not in the negotiating team. I was a scientist talking to other scientists from other countries and giving lectures on the importance of coal for India. Thank you very much, and let us start now. The topic of my presentation is energy scenario and its implications to climate change and sustainability. Today happens to be a Teachers' Day, but I always thought teachers cannot have a day on their own without the students. Without students, there are no teachers. So happy Teachers and Students' Day to all of you participants. As of today, you are students in this session, but you are all faculty members in your respective colleges. I wish all of you a great day today. And it is my good fortune that on this important day for teachers, Dr. Vasundhara and her organizing team in Hyderabad has given me this opportunity of interacting with you on a topic which is of very, not only great interest to me, but I'm very passionate about it. Right from the time I started working in the area of energy in the mid-90s, or even in the late 80s, this has been my passion. And so I will share some of my thoughts on this energy scenario today and its effect, especially on sustainability for the country. So Dr. Vasundhara and team, thank you very much for this opportunity. And we will start. Right in the beginning, I would like to acknowledge Mr. Arun Nagarkatti. He did his MS with me in IIT Madras. He is in the sustainability group of TVS Motors, Bangalore. He was the one, through his MS thesis, He did the sustainability calculations for various energy systems, and we developed a sustainability index to compare different energy systems. And I'm presenting some of his results today to just communicate to you that just talking qualitatively about sustainability is not enough. We should have a number. Always remember, my dear participants, qualitative things are okay for some discussion. But when you want to plan, estimate, project, predict, you require numbers. So numbers should add up. How much energy we need in 2047? Yes, what is the number? How are we going to achieve that? What are the energy sources? What are the technologies? Some numbers. Then we will see whether it is really meaningful, whether energy systems are really sustainable. So numbers are important. So in my talk today, you will find a lot of numbers I'll be giving because just theoretical information and qualitative information is not enough. Mr. Arun has done all these calculations, and through him also I learned a lot. About 10 years back, he did his master's with me. He is in the sustainability group of TBS, and also he assisted me in the last few days in preparing this presentation. Okay, so what is it that you should expect from this session? We call this learning outcomes, as you know, if you are in the outcome-based education, if you are following. At the end of this session, you will be able to, I hope I'll be able to do that for you, you will be able to summarize the important aspects of the Indian energy scenario. You should be able to summarize, write in a few words, in a paragraph. In fact, I'll ask you at the end of this session, if those of you who are interested, you can write a small summary of this and send it to me, and I'll be very happy to interact with you. The second outcome will be summarize is a slightly higher level outcome, but identify a few significant factors and parameters of sustainability, not simply qualitative things. So these two are my what I would like to achieve for you. You will be able to do this. I hope we will be able to accomplish that. Now let us start. So as a preamble, usually basic needs are given as food, clothing, shelter, but you please see for all these things you need energy. So right from the beginning, for man, he needed bioenergy in the first place, food. He was not growing it at that time. Whatever was available, he was eating. But over a period of time, you know, food, clothing, shelter, and so many other, about 11 basic needs of man, they have energy as their base. Without energy, you can't do anything. We know that. So if we take care of energy in the long run, the other things come automatically depending upon the societal conditions. The last century, 20th century, was one of uncontrolled exploitation of global energy resources by the developed countries for unsustainably high standards of living. Some of you, if you have traveled to some Western countries, advanced countries, industrialized countries, you will realize what I am talking about. This is unsustainable, what they are doing. Ours also is unsustainable, but in the other way. Most people don't have proper standards of living. 21st century, on the other hand, this century is one of expectations of correcting that greed which destroyed the global environment through an energy transformation. The greed for energy in the West, advanced countries, industrialized countries, made them exploit all fossil resources all over the world. They spew carbon dioxide and methane into the environment, left, right, and center. And today we are talking about environmental sustainability because of that greed. But whereas India, we are not greedy, we are, hungry. We are hungry, we are needy. We need energy for our economic development. I'll give you numbers on this. Consequently, the world is in the initial stages of energy transition. This term you might have heard a lot. We are transiting to a totally different energy scenario by 2070. That's what people are projecting. Whether that will happen, that's a big question. Transition towards a probable zero pollution future. Probable. It is not predictable. It is not, cannot be said with any amount of confidence that it will be achieved. So this transition time from one energy system to another is extremely important. For example, some countries want to have 2050 as a zero CO2 or zero net CO2. India has declared 2070 as a net zero dateline. China has given um, uh, 2060. These are all hopes. I'm telling you right in the beginning, the most important thing in sustainability for a country is energy security. Without energy security, you can't talk of energy sustainability. No way. Overall sustainability is different. Energy is just one part of it. Environment is just one part of it. There are so many other parameters which I will show you later. So transition time and energy security, the most vital sustainable parameter, demands our attention. With this, I directly go to electricity. Electricity is just one form of energy, but that's the most important today because we are going towards electrification, number one. And energy, which involves a lot of other kinds of energy resources and methodology to use in our transport sector, industrial sector, where you use oil, coal, gas, in cement industry, steel industry, everywhere. So total energy is called primary energy is different. I'm going to give you certain numbers about electricity only because that you are able to immediately grasp this actually. And it's very important. What are the current fuels? Fossil fuels, coal, natural gas, diesel oil. Renewables, solar, wind, hydro, biomass, waste and geothermal. But I'm telling you right now, this power generation from waste, geothermal, are very, 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 very small compared to what we have and what we need in 2047. By the way, 2047 is what our government has taken, that 100 years of independence. So we do all the calculations, estimation from 2047 point of view. Of course, nuclear energy with uranium. This uranium is imported. Most of it is imported. But for the future, India has this hydrogen mission. Hopefully it will work. And nuclear with thorium, which we have large amounts. This is a fast breeder reactor. But we have been seeing this for the last 25 years. It has made some progress, but nothing where it can be commercialized really. So hydrogen is not yet commercialized. By 2030, they want to produce 30 tons of hydrogen. They are developing the process and technology with foreign help. And hopefully, if that happens, from then onwards, hydrogen could be a fuel. But please understand, hydrogen is not a primary fuel. It is a secondary, it is a generated fuel from water. Whereas coal, oil, gas, solar, wind, hydro, bio, all are available in nature. But hydrogen is not available in nature, you have to produce it from water again through electrolysis. So these are the fuels. Now, these are numbers about our installed capacity, very latest information. Always you should look for installed capacity and importantly, how much energy has been generated from that. Because there is a tremendous difference between energy generated from coal, oil, gas plants, nuclear plants, and energy generated by renewable energy plants. So kindly see the total installed capacity as of today, 490, about 500,000 megawatt. I hope you are able to see the figures there. What I want you to note is, look at coal, 45%. Installed capacity today is 45%. And you go to gas, it's about 4%. So together, oil is very small, the diesel is very small. So about 50% of the installed capacity, not power generation, is still fossil fuels. Where is the other 50 coming from? Renewables means solar, wind, hydro mostly. And then hydro is 50,000 megawatt. Renewables are 1,87,000. Nuclear is still a very small amount. I have been giving this number for many, many years. It has not progressed at all. Anyway, totally it's about 490,000 megawatt or 490 gigawatt. But look at the renewable energy that is actually produced. Look at the solar. I'm sorry, this is in the renewable energy, what are the shares? In renewable energy, solar is 64%, small hydro is 2%, biomass is 6%, wind is about, I'm not able to see that here, 20%, 63, 65, 70, about 30%. This is the energy, installed capacity. This is different from actually energy generated. This is a more important graph. How much energy has been generated from these fuels and through proper technologies? Now you see that blue thing, that's all coal. Today, coal is generating 73% of our electricity, which we want to replace by renewable energy in course of time. 73%. And how much is renewable giving me? 14%, that green thing you see. Hydro, 8%. Nuclear, 3%. Oil, that's a small percent, diesel oil basically. And natural gas, 1.73. So for all practical purposes, if you look at fossil fuel electricity today in India, 73 and gas 2, 75 or 75% of our electricity is coming from fossil fuels. And we want to change it over 70 years. Let us see whether it's possible. And hydro also, it is 50,000 megawatt that is now added to renewable, so that they can say renewable is giving almost 22% electricity. This is sleight of hand, that's all. Large hydro has always been with us. But if you add it by a trick to solar and wind, it becomes larger. So the outcome from this graph is fossil fuel still contributes 75% of our electricity, and in that coal is 73%. Okay, we'll go to the next one. Now, the most important parameter for when we are talking about electricity for a country is what is the per capita per year electricity consumption. That's what I have given here. These are the things you should really know and work on this, rather than simply saying is high, low and all that. Total electricity production this year, 24, 1,830 billion units, 1830. This is called gigawatt hour if you want, GWH. But I like this billion because it's kind of comprehensible. You think it's a large number? We'll come to that. 1,830 billion units. That is, every day in India, we are producing 5 billion kilowatt hours of electricity. 5 into 365 days, 1,830. What is our population? 1.4 billion. Now, so the most important parameter for our electricity consumption is per capita per year. Look at the number in red. You see 1,307? It is nothing. 1,830 by 1.4 billion, that's all. 1,307 units per person per year. Please remember this. You think it's a big number? I'll show you other numbers. But we have losses of 17%, one of the highest in the world. Whatever we have produced with a lot of difficulty, we are losing 17% of that in transmission and distribution. Today they call it commercial losses. Okay. About 10 years back, I used to say 85,000 villages are still to be electrified. But today, under the present government, they claim all the 685,000 villages are electrified. So accessibility of electricity is 98% of the households, which is wonderful, a good achievement. But what does that mean? Are the people in the villages, are they really using a lot of electricity, or they just have access to it? Having access, having availability, having accessibility is different from affordability and actual use. But these are very good numbers that you should remember, actually, if you are interested in energy. Per capita, 1,307. Now, let us see what is the world situation. Where is India here? You have to search for it. Per capita electricity consumption in different countries. India is 1,300, just now as I told you. And where is it? It is much below world average of 3,700. We are almost 3 times less than world average. And which are the countries which are high? Look at Australia, 10,500. And then you have 7,100. 6,000 is China. 7,100 is China. 6,000 is European Union. And world average is 3,700. This is something which should shock all of us. We are talking about so big things about energy, electricity, environment. Look at our per capita. When are we going to go even to world average level of 3,700? How many more years it will take? So please remember this. Our per capita use of electricity is very, very low. Let us not compare ourselves with Africa and some parts of South America. No. We have to move up. We are the third biggest economy and all that we claim. But and also, when you say 1,300 average, it doesn't mean every person is getting 1,300, ladies and gentlemen. Some of you are, we are getting 2,500 to 3,000. There are 200 million people who use hardly few units per day, 2-3 units per day, or even less. So there will be 700, 600, 700 if at all they are using. So 1,300 is an average which we always take for calculations. So don't be under the impression that everybody is getting that. Okay. So now let us see. Please look at this graph. Why are we talking about per capita? Because according to the Western economists, per capita electricity or per capita energy consumption tells you where we are in terms of world economy, in terms of GDP. Now here the abscissa is GDP per capita, and on the left side you have electricity consumption per capita. You can see that, see this is India here. So India, as I just now mentioned, about 1,000 plus units per person, and the GDP is about $2,000. Now you look at these countries here. Look at United States, 12,000 units. Ireland is much higher. I cannot even show you how much. Iceland is, of course, small population, so 20,000 or so. So here you have United States. Look at Japan, 8,000. United Kingdom, 6,000. Poland, Greece, these are all European. Saudi Arabia, of course, is rich in oil and gas, so it can, and the population is low. Look at China now. China is our competitor, or we are competing China. They are having around 6,000 units, 7,000 units. And therefore, their GDP is very high. Their GDP is, somewhere here per capita. So they are about $10,000 per capita. Ours is hardly $2,000. Even then, we are third economy. But that should not take away from the fact, really, we are nowhere. Very few people in India are getting this kind of salary and income, and also using electricity. So my point is, our per capita is extremely low. Income per capita, GDP base, is very low compared to Western developed countries. Now let us go to energy. Energy includes everything. Transport energy, that's oil, coal, gas. That was only electricity. Now I will not give the details. Look at the, again, on the abscissa coordinate per capita primary energy consumption. Always take per capita. Per capita is extremely important because GDP is associated with that. This also we should look at capita. Electricity, energy, and carbon dioxide. Where is India? 700 kg of oil equivalent. 1 kg of oil is 11.6 kilowatt hour. And the world is at 1,851 today. By 2047, will it keep at that level? When are we going to pass this to say we are a world economy, a leading economy? And look at the other countries, and look at Australia, 5,000. Germany, almost 2,925. Ladies and gentlemen, per capita electricity, per capita energy consumption, India is on the lowest side. Don't take Africa. Africa is a dark continent. Don't look at it. If we want to become a superpower, where is electricity consumption? Where is energy consumption? Okay. So that is the present situation. Per capita is very low, electricity and energy compared to the rest of the world. We have to increase it. How much we have to increase? Now comes Niti Aayog has this IASS, Indian Energy Scenario, Energy Security Scenario 2047 projections. You can go to the Planning Commission Niti Aayog website. This actually, you can play with this program. You can put whatever numbers you want and get it. But I'm not going to do that. I'm going to give you some numbers which are in the projections. Till now I gave you what is the state of affairs. Now what is the projections for 2047, which is the 100th year of our independence? Our population will be 1.6 billion. And there is some kind of a calculation somewhere, not calculation, understanding that for a country to be considered developed, economically developed, it must have at least 6,000 units per capita electricity. 6,000. Why? In the European countries, The average today is 6,000. That is the reason. So you cannot really say what is the actual number, but this is considered so. So if India wants to be a, as our government says, a developed economy by 2047, we should increase our per capita from 1,300 to minimum of 6,000 by 2047. You have 22 years time. But please understand, by that time, other advanced countries would have still moved up with some stabilization. So we require 9,600 billion units in 2047. And today it was, you saw this 1,830. So we have to increase our energy generation by 5 times in 22 years. What are the resources available? Can renewable energy alone take care of it? Where is the finance? Where is the technology? Where is the land? Where is the manpower? It's all very nice to say, sustainability, energy security, and actually, you know what? I want to talk about energy insecurity of the country, not energy security. We are highly energy insecure. Please think about it. By the way, don't take anything coming from me as Bhagavad Gita, please. I'm giving you information by my experience. You can check it on it and think about it. But in this 9,600, I don't think we have included 5 important new developments in the country. EV requirement. EV, they require, you say EV reduces pollution, but you are using electricity from fossil fuels today to run EV. So instead of polluting your cities, coal, oil, gas are polluting somewhere, somewhere the energy is being generated, it's been transmitted to you. How can you call EV as a sustainable, environmental friendly technology? I don't understand this. If you run your EV on renewable electricity, that's okay. But are we doing that? We are nowhere near that. Then air conditioning. As we move up in our middle class is now 300 million, out of our air conditioning requirement will go up because of heat requirements, number one. Secondly, people will be able to afford. Yesterday, the air condition prices have been reduced. Data centers, you are talking about artificial intelligence. You know how much power they need? In one of the developed economies, I found 12% of the electricity goes into data centers. Here we are only starting now. I don't know how much more we require because of that. All this you have to add to the numbers I have given above. Then increase GDP. Today, our GDP growth, the rate is GDP is what? 6.2%. But if India wants to be a developed country by 2047, minimum 8% GDP growth must be there. We are not even planning for that. A 8% GDP growth is a tremendous amount of electricity and energy requirements. Today we are 6.2, we are struggling between 6 and 7. We have to go to minimum 8% for the next 22 years. Where is the electricity coming from? Then finally, everybody talks about electrification. We will electrify transport, we will electrify your house, we will electrify you, I will electrify robots. Where is electricity coming from? We are not even meeting the minimum required for a common man. We are 1/3 below the world's average today, but all these things are coming up fast. We can't wait to meet these requirements. Now, the projections say our demand of electrification demand is going from 20% today, approximately now, to 40% by 2047. So, if by 2047, 40% of all our activities, industries have to be electrified, what electricity do we need? What more electricity do we need? Please think about it. Now, this is the projected installed power capacity. At the left hand, you will see 2020 gigawatts, that is 1,000 megawatts. Today, let us take 2025 is about 500 gigawatt, right? Now, if you go to the right, 2047 at the right extreme, it will be 2,200 gigawatts. So, from 500 to 4 times, 4 to 4.5 times additional power capacity has to be installed, and whatever energy comes out of it goes to our per capita electricity. And you know something else? You see that yellow thing is solar, light blue is wind, topmost is green, okay? But come to the bottom, you see the coal reducing, that bottommost gray thing, from 2037 it's reducing, around 2035. Their projection assumption is that by 2030, coal use will peak for electricity generation, and then it will reduce. On what basis? Even when you do that, at the end of 2047, you have a substantial amount of electricity generated by coal and gas. By the way, I want to mention here, ladies and gentlemen, don't think that 1000 megawatt coal generation is equal to 1000 megawatt solar or wind. No, the capacity factors are very low for renewable energy. It's very high for coal. So approximately, if you want to replace 1000 megawatt coal plant or natural gas plants today are 65% efficiency, ladies and gentlemen. Coal is about 40%. Renewable is solar is 21%. Wind is maybe 40%. But they are available only 1/3 of the year, solar and wind. I'll come to that. So their capacity utilization factors are very low. So this yellow and the top three colors, their total output in terms of kilowatt hours may be just a little bit more than coal, oil and gas. Meaning, not oil, coal and gas. In 2047, ladies and gentlemen, the projections themselves say this doesn't mean that we are going to do it or it will be achieved. Hopefully, they will be done. We need coal and gas in 2047 in very substantial numbers. Today, we are mining and using 1000 million tons, 1 billion. We crossed 1 billion tons of coal production, and all that, most of it goes for electricity. In 2047, we still are talking about 1.5 to 2 billion tons of coal. And I'll tell you something else. Please understand. All this is assuming from now to 2047, the world will be at peace. There will be no wars, no demand for oil, gas, and additional oil and gas. That's, I think, is a big assumption. Today, we are already seeing the effects. Hello? Am I audible, please?
Yes, sir. Yes, sir.
Yeah.
Please continue, sir.
Yeah. So all these calculations, projections are based on the fact that world will be at peace. You think so? Will it be? Ukraine is going on, Indo-Pak will go on, North Korea will go on, Taiwan will come up, and with a new president in the United States acting in his own way, anytime anything can happen. I'll tell you, one disturbance of, look, Ukraine war itself, how it has disturbed the oil supply and gas supply in the entire world. And if there is a much bigger war, and I think all indicators are that there will be a big war, all these calculations go to naught, and we have to fall back upon coal. Why? Coal is the only big fuel we have indigenously for the next 200 years. We don't have oil. We are importing 85% of the oil. Gas, the available gas turbines, because of imported gas, they're running at 20% capacity factor. Nuclear and coal are operating at 80% capacity factor. Solar and wind, 25%. Just because sun and wind and moon and fire and earth, they've always been with us. Just because it's there, you cannot simply imagine things and come out with what can I say? Fancy numbers. It's good. Projections are good. That will give an idea. In fact, this will give an idea what to do with the wind, the solar, and so on and so forth. So my purpose is here. One of my the outcomes from here should be for you. Let us not put all eggs in one basket of renewable energy. We need coal because we have it. We don't have to beg other people. We still import 10% of coal because our coal is high ash, so low calorific value. Many of you who teach this would know. So new technologies have to be developed. And then we should take the coal and gas to higher levels. Unfortunately, we have very little gas. Okay, then we'll go to the next one. Look, final energy demand. This is million tons equivalent, that's how. Look at the right extreme, that is 2047. What I was saying just in the last one. The bottommost blue, I think, is coal. Next is oil and gas. The top three are solar, wind, and biomass. Now you look at it. 2047, we are talking about up to here, here, This is 8 here. 1,000,000,000 tons equal of fossil fuels, ladies and gentlemen. Coal, oil, and gas. And above that, whatever is coming above that, that is about 800 to 1,000 to 400, 500. 800 million tons equivalent of fossil fuels, 400 million tons equivalent of renewable energy. So how can you simply forget about coal, oil, and gas, especially coal? Ask yourself a question. Can we just do without coal, oil, and gas? Oil anyway we are importing. I'll show you another slide how much insecurity we have with that. So we'll go to the next one, please. I'm giving you these numbers. You may not remember everything, but at least remember in an overall sense that the projections are still based on using coal, oil, and gas in 2047. Don't be under the impression that some magic will happen and everything will be hunky-dory with sun, moon, earth, wind, and fire. No, it will not be. It's not only the availability of the resources. Where are the technologies? Now, this is the primary energy supply, very similar thing. Primary energy supply 2047. You can see now bottom three: coal, oil, gas. So 1,000 million tons here, primary energy. And that green is only renewable, this one. It's a small amount. It's not small, substantial, but much less than. So these are all not my projections. This is Niti Aayog. So 2047, coal, oil, gas will still be important. Renewable will contribute maybe 40%, 50%, but still 50% has to come from coal, oil, and gas. And we have coal in India available for 200 years. Oil, almost zero. Gas, some things available, but the industry people have destroyed it. They have misused it, abused it, and not doing a good job to give available in Krishna Godavari basin. I can't tell you what they are doing. This is the, I think, last of the energy things. Let me see. This is again Niti Aayog projections, not mine. They are talking about import dependency. How much are we dependent on imports? Can you see this? The top one is oil, 85%. Now we are 85%. In 2047, it will still be 80%. Because we don't have a single drop of oil as of today. And unfortunately, yesterday, our government has increased the GST on coal, oil, gas exploration. Can you believe that? They're very good. They have reduced the GST from 12% to 8% or 5% for renewable energy. Fantastic. But they have increased the GST for oil and gas exploration. So it's almost as if we have given up on oil and gas. We'll continue to import it. And ladies and gentlemen, anything you import, not only energy, food, clothing, shelter, cosmetic goods, you are not secure. There is no security. Anybody can stop that flow of those things into your country. Like Trump says, don't buy oil from Russia. You have to stop it. Tomorrow, Saudi Arabia says, I'm not going to sell oil for you. We are doomed. We have coal, but we don't want to do much about it. Anyway, so look at oil. Gas. That is the end you see here. So this is 80% dependency of gas, 70% dependence on gas, and non-coking coal. Coking coal. This is coking coal. This is required for the metallurgical industry. We're completely dependent even today. It requires very low ash, less than 10% ash, and we don't have that. Our coal is 40 to 50% ash. So very low calorific value. So you come to coal, finally, that bottommost. So you can see very beautifully that this, they're all my friends who have done it. I know them and I respect their calculations, but it is as if planned in 2032, we will stop reduce using coal and drastically. This is a hope. This is the only fuel we have for energy security. 1.2 billion tons per year, if we mine, We'll get it for, we have it for 150 years. I'm not saying we should use it for all the 150 years, but if you develop carbon dioxide capture technology, not only we can use coal for a long time, gas for a long time, we can export it. Nobody is talking about it. It is as if we have accepted we should stop coal because some Western countries are telling us. Ladies and gentlemen, energy is not only science and technology, it is geopolitics. Please understand. Today, that example is, I don't have to give any other example than what Trump is doing to India. The whole discussion is on Russian oil. Okay, so this is import dependency. So my point here, we will be highly dependent on oil and gas and non-coking coal even in 2047. But unfortunately, we are also projecting very low dependency on coal. This is import dependency anyway. So we'll be importing less. Hopefully, we'll be using more of coal. And will be 1.5 billion tons. We have to, otherwise you won't get you or your children won't get electricity. I'm not bothered really about the future generations as what is your sustainable development goal say. I want electricity today. If I'm hungry today, I need food today, not one who, if my next generation food, I want food today, I want energy today, I want electricity today. Okay, so what are the challenges? Renewable electricity being highly intermittent, all of you know this, but I want to emphasize, fluctuating and unpredictable leads to three major challenges. Grid balancing, not many people are talking about. You can't simply go on adding renewable energy and connect it standalone, no problem. But grid connection, a huge problem. So they are spending billions of rupees, crores of rupees, thousands of crores in improving the grid system. So just because sun and wind are there, only 1/3 of the year, don't think the problem is solved. That they will help us for in perpetuality. The grid structure has to be changed, and they're doing it. And I appear to be very critical, yes, but they're doing a great job. Our people are doing a great job. Grid balancing is happening. A new grid structure is being implemented. Now, this electricity storage. Now tell me, ladies and gentlemen, sun is a morning 8 to 5 or 9 to 5 office goer. Huh? He's not available to you after 6 p.m. He won't come up till 8 a.m. throughout the year, and it is sustainable. It is not that it's going to change in 2100. As long as sun and you and I are there, he gives electricity, sunlight only during those hours. And then wind is June, July, August, September, 4 months, monsoon season. So together, if you take, sun is available 1/3 of the year, 8 hours, 9 hours a day. Wind is available to you for 4 months. How can you run a country on energy sources which are available only 1/3 of the year? What will you do? Then you come up with the battery storage. Excellent idea. If already there are plants which add battery storage to the solar plants and they are able to operate some 3 to 4 hours. We need about 3 to 4 hours of storage, some gigawatt hours. But gentlemen, where is the technology for battery? We are importing. What are you importing? Lithium-based batteries. Where is lithium? Nothing in India. It is all in South America. Chile, Argentina, and one more country. And that lithium is already taken by China. Australia has lithium, so we can bargain with them. Vietnam has little lithium. China is almost 90% of lithium in the world is controlled by it. So all electric, that's why Tesla wants to go to China. So if you develop electricity batteries with Indian available, our indigenously available material with our technology, our R&D people, then some hope is there. You can't have so-called sustainable sun without electricity storage. So if two sources are not available to you on a daily basis, how do you call it sustainable? What is the meaning of sustainability? Everybody talks about it as if it is their birthright. Power stations based on other fuels technology, especially and gas have to come online. Today, that's what is happening. So today, not only they are giving us electricity in the daytime, they are also working so they can work 24/7, coal and gas. Not sun, not moon, not earth, not wind, not fire. Panchabhutas. Can renewable energy meet the complete electricity demand of the country? My answer today is no, at least for the next several decades. And you want to wait for several decades for you to get at least 3,000 units per person, we will be wallowing in this 1,300, 1,500, 2,000, 2,500. When will you become a power, economic power? Just by the government declaring from the Red Fort doesn't mean doesn't happen, that will become. Where is the resource? Where is the technology? Where is the manpower? Where is the finance? So if not, what is the optimal percentage contribution? This you have to calculate. I'm raising a lot of questions for you. I'm giving you the present situation in a very honest fashion. And I'm not politically correct always, by the way. Okay, so that is the energy scenario part of it. If you have, hopefully you have taken some points. You can later at the end of the session write a small summary of 8, 10, 12 lines, and those of you who are interested, you can send them to me. I will be happy to interact. I'll go to the second topic now for next maybe 10, 12 minutes. I think already you had climate change topics dealt with by experts. And also, I think one more, Dr. Vasundhara, I think is going to speak on that tomorrow also. So I just want to again bring you the CO2 ppm levels. Climate change, you know what's happening. Unpredictable climate, flooding and flash floods, cloudbursts, coastal submergence, heat waves, human health affected, biodiversity, agriculture, everything is affected socially. Very correct. And we are seeing the effects of it. But for you gentlemen, ladies and gentlemen, I want to also tell you all these, okay, I'll come to that when we come to the prediction. Generally, it is accepted that today's unpredictable climate changes are because of mainly one, carbon dioxide, extra carbon dioxide in the environment, a little bit of methane, a little bit of nitrous oxide, which is only by correlation. This is by correlation. Some scientific background is for that. We should accept it as being scientists. So these are caused. Why? It is caused by global warming, as we talk about now, due to extra CO2. You know, this greenhouse effect. You and I are able to live on this earth because of the greenhouse effect. You should understand. Otherwise, in Mars, it is 800 degrees centigrade or something. In another planet, is minus 50 degrees. Earth is the only inhabitable planet for us human beings, maybe because we are used to it. Because there is CO2 in the environment, because there is some methane in the environment, they keep us the temperatures in the range in which we are comfortable. What is happening is there is an enhanced greenhouse effect. So more CO2 is now in the environment than what optimally it should be. What is that optimum? We still don't know. But definitely it has increased from the industrial times. So this is caused by carbon dioxide, methane. Do you know there's a lot of talk of CO2, but what about methane? Natural gas is 95% methane. So now the West is forcing us to use more and more gas instead of coal, which we have. Gas we don't have, so that they want us to import it. But there is CH4. When you burn it, you will get carbon dioxide. That's okay. But you know, please, those who are interested, find out how much methane is being leaked from natural gas pipelines in Europe and the United States. And how CH4 is a much more potent global warming gas, although it stays for a shorter time. CO2 stays for a very long time. Nitrous oxide actually N2O and HFC, that is fluorocarbons, perfluorocarbons, sulfur fluoride 6, then nitric trifluoride, and you know H2O. Water vapor is a big greenhouse gas because but it is somehow protecting us. So these are the identified 7 so-called greenhouse gases. They are called greenhouse because they are now warming our country. Why? I'll give you an example. CO2 is increasing the atmosphere. Again, we want numbers. Please, we want numbers. By the way, I attended this COP21, as I said, to talk about coal. There we have given certain promises, not legally binding, but promises. So what we have said, by 2030, 50% of the installed capacity by non-fused resources by 2030. According to government, we have already reached it 5 years in advance, because we have 180,000 megawatt of solar and wind, and if you add 50,000 of hydro, large hydro, that is about 230,000 megawatt, which is slightly more than coal. So we have actually reached it. We are one of the very few countries in the world. We have kept our promise in the Paris Accord. Many developed countries are just not bothered about it. Then 45% reduction in emission intensity. These are all our commitments. CO2 per GDP, that's called the CO2 intensity, GDP intensity, that's also going down. Forest cover for 2 to 3 billion tons of carbon dioxide absorption by 2030. So I was one of the in the committee when we, from India, what is it that we could commit ourselves. There's a committee in TIFAC. Some of those things also have gone into our commitments. So this is what finally India committed. Again, I'm saying I was not on the negotiating team. Dr. Ajay Mathur was our boss at that time. Now, but to meet these, there are some conditions. Paris has agreed. The most important condition is developed countries contribute $100 billion per year to global climate fund to meet these environmental. Ladies and gentlemen, they have not done anything. So instead of 2020 as the starting point, they pushed it to 2025. Today they have given some money, a few millions of dollars, but not as a grant, as loans or whatever they have given earlier. They say West is not interested, except a few countries in Europe. They are not interested really. And you think it's all come from the United Nations. So United Nations is an important organization as far as these things are concerned. It is just an advisory body. It doesn't have the enforcement power. You will see the United Nations Secretary General going all over the world, asking for peace, asking for environmental agreements and all. He is not able to stop the Ukraine war. He is not able to stop the Gaza war especially. So UN is just a showpiece in a way, and the people in the UN are very good. I mean, they want to do an honest job. But the powerful countries, United States, Canada, Europe, they are not allowing them to do that. And we are not there in the Security Council. We are a very weak country from international power point of view. So developed countries are not doing their job. Advanced technology transfer to developing and non-developed countries. Not. So you want to use sun. Where are the panels coming from now? Ladies and gentlemen, they are coming from China. Only recently we have started manufacturing the solar cells. So all these industries are cheating us for the last, say, 10, 15 years, saying, oh, we are manufacturing solar panels. Nonsense. I'm sorry. They get the panels from China and some other, and assemble them here and say we are manufacturing. Our industry is one of the most slavish mentality they have. They don't want to spend money R&D, research, development, deployment. They want cheap answers, cheap technologies imported. You please think, you look into literature. What energy-related technology has Indian R&D community with the cooperation with industry has developed? Nothing. I can assure you nothing. Sun is there for what? Millions of billions of years. We know we can extract energy. What did our industry do? What did our R&D? I'm including myself in that, by the way. We publish papers and forget about it. Where is the technology for sun? We're importing. Now you want to import lithium for batteries. Why don't you develop some novel type of battery in India? Yeah, IITs, we are doing research, but research doesn't go to commercialization. It has to be developed. Technology has to be developed. It has to be pilot plan, deployment, and so many things have to. Industry, no, they will not do it. Even in the green hydrogen mission, ladies and gentlemen, the big industries involved, I don't want to name, their advisory committee is full of foreigners. There's only one Indian out of 20. And they're trying to buy technology from outside. Luckily, hydrogen, everybody knows about the electrolysis of water. We know that. We know it from the laboratory. But it has to be done on a large scale. It should be economically viable. We have planned anyway to get 30 million tons of hydrogen by 2030. If they're able to do it, I'll be very happy. My hats off to them. But solar, only now we have started. Look at chips. Forget about chips. What are we doing? Only now, the government has declared some. Yesterday there was a summit, chips and all that. Where are we in terms of technology development? You and I, faculty, we do research, publish papers, maybe get a best paper award, get a promotion, and then say goodbye. That's all we can do, maybe. But some of us must be involved with industry to develop the technology. But industry is not interested. Because industry says, I want the solution now, today, but I'll pay you later. We say, you first pay me the money, I'll develop at least the science part of it, you develop the technology. I was involved, I'm talking with a lot of experience, fluidized bed combustion of coal, 35 years back. Even today, it is nothing really worthwhile has happened. Coal gasification. If you ask the big people in some big industries, they say, we have the technology, but there is nobody to buy. We are one of the poorest. All of us still have the slavish mentality from the West. Somehow, we want the West to approve in everything related to our life. Okay, I have only 15 minutes left. So advanced technology transfer has not occurred. Why will they give? I don't understand. Why will America or Canada give us a technology which they have developed? But our government suddenly has announced about 4 years back. This is a very, very diplomatic thing our government did, net zero by 2070. What happened? They were pushing us for 2050. The West, Europe, please look into it. They can do anything within 30, 40 years. India cannot afford to do it. Our population is so high, requirements are so high. So by 2070, that was the United Nations Assembly that Mr. Modi announced, and we were all thrilled that he did that. But China has given 2060 as net zero. Modi went one step ahead, 2070. That's a very good thing diplomatically, politically. Do you think for the next 45 years, the world will be at peace to follow these things? 45 years to reach this? Yeah, it's a good idea and we will try to do it. But one big international conflict, everything will be done. Because international conflict, war happens when energy is available. We always say the Second World War would not have happened if oil were not there. You know what? All their planes and ships were all oil fired. Future wars will be different. Cyber attacks, bio attacks, poisoning water and viruses like COVID, all that will be done by some countries. But otherwise, we have done a good job by 2070. I hope I will not be here at that time. I hope many of you will see this 2070 net zero. I only have lots of doubts about it. So CO2 ppm, this is what we have to look at, CO2 parts per million. I'll show you this. In the industry levels, it was 280. Pre-industry, 1850 and all, it was 280 ppm. Now you see already in 1960, it has come to 310, but this is important. I started my research sometime in the mid-80s here. See how it has gone up? And today it's about 430 ppm by volume. CO2 only, not all greenhouse gases. But I want you to know these numbers. Then you should ask yourself, what is the optimum or maximum ppm we go? Nobody knows. Because that requires what temperature rise you will accept in what time period. That's what the UN report says. Either 1.5 degrees or 1.7 degrees or 2 degrees increase by 2100. They have given you 75 years time. Is it possible? Because once CO2 gets into the environment, it will take hundreds of years for it to come down. CH4, maybe slightly less. So you can see different scenarios. I want you to see that the 400, today it's 430 parts per million, and it is only going up. These are all different scenarios. You don't have to worry about the numbers. The point here is they're all going up unless we do something about it, which is very correct. And this graph is also methane. Don't forget, methane is a big global warming gas. It's not only from natural gas leakage. A big contributor is cattle when they give out gas. So a lot of research has gone into it. Therefore, some of the Western people have used that fact to say, oh, we should reduce agriculture. so that you can, this rice on the field and the water, they give out global warming gases. But cattle, millions of cattle, they give out methane. So all this is happening. So there is an Asian brown cloud over India. So we should stop using cattle. Therefore, you should reduce your agriculture. That's why Trump is putting so much of tariff. He wants tariff on agriculture. Luckily, our government has really stood up to him. If we allow high tariffs on agriculture, our agriculture will be doomed. Our farmers will be doomed. But that's what United States wants. One point I want to make here. Please understand, we don't have any real big friends in the world. We have to fight it alone. No country in the world wants India to be an independently strong power. America wants India to be powerful enough to take on China in case. And that's called the Goldilocks principle. Find out what the Goldilocks principle is. So what is the total emissions? Total Indian carbon dioxide emissions is 4 billion tons. This is a very important point. You should know 4 billion tons. And what we should again look at is per capita is less than 2 tons today. See, just like I showed you per capita electricity. And this is latest. In fact, this 53 billion tons you are seeing is I think 24, 25. But see who is emitting the most. China, 30%. United States, 11%. Then comes India, 8%. Total. 8% of the 50 billion. 8% of 50 billion is 4 tons. That's what I have written here. 4 at the top. Here. Total emissions. Now, I'll show you the per capita. Look at this. Isn't it just like the per capita electricity? Look at where are we? Now, maybe it is closing to this is the old one, by the way. I'm sorry, 2017-18, I was not able to. But relatively, you can see who is per capita, who is emitting more. Look at Australia. Look at Germany. And these people tell us we should stop using coal. Look at the European Union. Today, European Union is still importing oil and gas from Russia. To the extent that yesterday Trump said he advised the European Union to stop importing Russian oil. But he wants to put 25% extra tariff in India for doing the same thing. Hello? China is buying Russian oil. European Union is Russian oil. We are buying Russian oil. We are buying Russian oil because the United States government told us 5 years back, please buy more oil so that the prices will stabilize. And now he turns around us. The so-called friendliest country, we thought, is now completely turned against us. Don't believe anyone in the world. We want to be self-sustaining society. We have to depend on ourselves. Nobody is going to help you. Why will any country help you to become powerful?
Income tax returns file చేసావా చిన్న రిటర్న్స్ ఫైల్ చేసావా?
Shall I continue, please? Shall I continue?
Yes, sir. Sorry for the disturbance.
That's okay. Look at the world average, 4.4. My point here, ladies and gentlemen, whether it's per capita electricity consumption, per capita CO2, we are nowhere. Yeah, we are emitting CO2, but we are nowhere. But the world has targeted us, especially the West. The Western countries have great double standards. They want India to be just strong enough to fight China because they don't want any war in Europe and America. Have you heard of any war in America so far? I'm sorry if I'm bringing a little bit politics here, but it is so. It is geopolitics. My last slide will tell you it is all geopolitics. It's not entirely based on science and technology, this energy and emissions. It is lobbying, biggest lobbying going on in the Western countries against coal, against oil and gas. Yeah, there is some scientific background, but then we should be developing technologies on our own to use more of our coal rather than succumb to their pressure. Okay, because I think only 10 or 15 minutes more. This is the last one. This is again from the projections of the IESS. So you see million tons of CO2. 1,000 million tons is 1 billion. So you will see here somewhere according to this projection, this is official IESS projection. You can get it from the Niti Aayog. Here you see 3,600, that is 3.6 billion tons in 2037. Nothing. compared to what other countries are doing. This is total emissions by India. Total energy, not only electricity, not only CO2, GHG. Even if we try very hard, we can't exceed CO2 emissions per capita and total of even today's world average, ladies and gentlemen. Don't feel very, they are making you feel inferior. Oh, we are doing that, we are doing this, we are polluting the environment. No, it has already been polluted, over polluted by the Western countries, and there is what is called as a carbon budget in the total amount CO2 that the atmosphere can handle, so that the temperature rises 1.5 maximum. 80% budget is already over by the Western countries in the last 200 years. In the rest 20%, which is about 300 or 500 billion tons per year, we are only giving 3-4 billion tons. They are emitting 15, 20, 30 billion tons. In 10 years, everything, the budget will be over. That means more and more carbon dioxide, more and more global warming. And they're ready for that. Please don't believe what they say. And I'm telling you with all authenticity, with all my sincerity, honesty, and my experience. Okay. Okay. So future, have you heard of futuristic geoengineering? This is called CDR, carbon dioxide removal. You see, the West has created the CO2 problem. Now they want to come up with technologies to solve that problem. They are not doing it. We cannot do it because we don't have the expertise, we don't have the money. Then what is the solution? How long will this take? So CDR, those of you who are interested in research, this is a very good area today, CDR. And SRM, solar radiation management. See how they are playing with nature. They want to reflect the solar radiation coming in through some gases or particles or water. The West has created this problem by spewing uncontrollable amounts of greenhouse gases from 1850 to now 2000. The whole world is suffering because of them, not because of me, but I'm suffering, so I have to do something about it. But is all the responsibility for me? So this is called CDR. Common but differentiated responsibilities. So this is about CO2. I'll now go to the last part. 10 minutes I'll take, and I think I don't have much time. Sustainable development goals, the development goal number 7 is energy given by United Nations. First, define sustainability, Baba. Simply everybody talks about sustainability. Give a proper definition. Anyway, for me, energy is a concern. So energy for all 24/7. That should be my energy sustainability. Please differentiate this from environmental sustainability, food sustainability, shelters, housing sustainability, defense sustainability. These are all different. But the West has coined one word. They only mean environment. They don't mean other things, because everybody is happy there with 15,000-20,000 per capita electricity consumption. So for you to say this is my criteria, you can, as I said, don't take whatever I say as Bhagavad Gita, you think about it. So for you to call energy system, not energy source, a system, sustainable, is the availability. That means the fuel and the technology must be available. Accessibility, they should be accessible, not simply available. Affordability, I should be able to pay. This is a big problem in the Indian rural area now. 685,000 villages are all electrified, but many of them are not using because they cannot pay, or they are stealing. Both are possible. Acceptability. So now CO2 is not acceptable, but solar is acceptable. So energy system must be acceptable. And it should assure me 24/7. Solar and wind will not assure you 24/7 without battery storage. That means you are developing enabling technology to make the otherwise unsustainable sun and wind to be sustainable. Then same thing with coal. Coal we have for 200 years. Why can't we? The only problem with coal is CO2. Why don't we develop technologies to capture CO2 and do something about it? You develop battery for solar and wind, but then you say coal, no, let it be there wherever it is. Why? The West is telling us to do that. And we don't have the confidence, capability, our industry to develop CO2 capture, sequester, and use technologies. No, there is a mission at the government level purely for research purposes. We are not serious about it. If India can develop, this is called CCUS, carbon capture, use, and storage. If India can develop, even in the next 20 years, we can rule the world, use our coal for another 200 years, and sell the technology abroad. But we don't have that confidence in us. We still have that slavish mentality. Anyway, the last one is all inclusivity. Everybody must be inclusive. It applies to us. You and I, actually, if you go and calculate, take your meters, your electricity meters in house, calculate per capita per year how much you are using. I'll tell you, most probably you are using between 2,000 and 300 units in your houses. Per capita, at least definitely 2,000 to 2,500. But there are villages where they don't have that much. They have 100, 200. Today, one electric bulb, if it is there, you say that electric bulb in a house, that is electrified. What irony, huh? You and I have air conditioners, or dishwashers, washing machines, and TVs. They don't have anything. 250 million people don't have food, no food security. Nobody talks about it. 250 million people don't have access to electricity. It's not that we don't know. We are kind of covering it up. We are good in covering. We should actually discover that. Okay. So, there is nothing like a sustainable energy source. We talk about energy system in the next 5 minutes. I'll wind up. See, these are all the factors that are going to make something energy system sustainable. Any system. So look at from the top. Energy that is required for the system. Economy, that is the cost. Land, how much land is required for solar, or wind, Now environment. Please see, environment is only one aspect of the total sustainability. The word you are using, sustainability, the meaning is environment. That's what they have told us. But no, there are many aspects of sustainability that should go into our calculations. Then what is the impact on society? For me, most important thing for sustainability is energy security. If you are energy secure, you can't be sustainable. Then politics comes into picture. Not only national politics, like yesterday our government has increased GST on coal, reduced it, which is okay, no problem. But I'm talking about geopolitics here. Some countries don't want you to be strong. They don't want you to have more energy and power, just enough to fight. That is, they want us to fight China on their behalf. Okay. Then what about not only water used for energy system, but what about drinking water? That should be sustainable. Waste generation. Coal generates a lot of waste. You think solar doesn't generate waste? At the end of 25 years of life of solar photovoltaic, you know how much waste is generated, electronic waste? Even today, you know how much electronic waste is generated because of the computers, laptops, and mobiles? We are not opening our eyes to the realities. We are simply accepting whatever somebody says. And material. The example have the material sustainability. For EV, you require lithium. For battery storage. For solar photovoltaic, you really require a lot of silicon-based cells. You require rare earth elements for your magnets. Do you have it? Do you have the technology to process them and use them? Without all this, where is sustainability, ladies and gentlemen? So, what we did, here is one thing. I'll just go to the last one. This is one important outcome, if at all, from my lecture. In what sense are they sustainable resources, solar and wind? Instead, we should talk about sustainable use of energy. Please think about it. Don't accept it from me. Sun is not sustainable energy source. Wind is not sustainable energy source on their own. You have to have battery technologies. You have to have proper grids. You have to have photovoltaic manufacturing ability, battery manufacturing ability, materials. How you use the available source, that is important. So you think about it, and if it's right, you say you can work on that. We should talk about sustainable use of energy rather than talking about sustainable energy resource. Solar is 9 to 5 office goer. Wind is 4-month guest. Their efficiencies are low. We don't have the proper technology. We are importing the technology. And then how can you have no energy security? No energy security means no sustainability. Energy security is an important aspect of total sustainability. So what we did, we have made my student Arun Nagarkate has made all these calculations. I will not go through those details. That's not the purpose. Now, we have to develop what is called a sustainability index for every energy system, which involves a lot of factors which I have mentioned. We have taken that 5 dimensions into that. Now, when we develop that, I won't tell you the procedure. Just look at the numbers. The sustainability, maximum sustainability is 1, 0 to 1. We have classified all the available energy systems. There is some subjectivity. But see the numbers here. Coal 0.51, gas turbine 0.57, nuclear 0.68, hydro 0.64. I'm interested in solar and wind. They are nowhere near 1. They are also okay, 0.69, 0.69, because they have their own disadvantages. And biomass is 0.47. In fact, I would say nuclear is one of the best. But this is one scenario. But I'll show you, these are all calculated by me and my student, rather by student and by me. So we should take this. Look at this, we have 5 dimensions for calculating the sustainability index: resource availability, energy efficiency and all that, environment we have put there, economic, that is finance, and social impact. Please look at this indexes. Coal is 0.45, nuclear 0.73, and where is solar and PV? 0.6265, which is okay, nothing great about them, because they are not available, the efficiencies are low, we don't have the technology, and their maximum potential is not much actually. This is okay. I will skip this. Now we checked various other coal systems, advanced coal, subcritical, supercritical. Some of you who do this, as we improve the temperatures in combustion and the material and add CCS, you see CCS here, carbon capture technology here, carbon capture storage, I can increase the sustainability of coal to 0.73 from 0.4. That means sustainable use is important, not the source itself. That's what I'm trying to say. Whether it's solar, wind, or coal, how you use it, what is the technology we use, that's very important. So with this, we calculated here the best coal technology, super critical with carbon capture and storage, as you can, versus renewable energy. You see, which the coal, which was only 0.5 or 0.4, has gone up to 0.63 here, and nuclear. But look at hydro, solar and all, they are on 0.65. Coal is of the same order if you develop enabling technology like CO2 capture, like you develop battery for enabling technology for solar and wind. Okay, so the Indian electricity situation demands that a judicious mix of all indigenous energy sources and technologies must be used without bias towards any particular resource of technology. No coal, no oil, no, everything is required. This is good for the stable and steady supply of electricity 24/7 for the entire population, which leads to true power security. Life cycle assessment of competing energy systems and sustainability analysis leading to a we should do a LCA, life cycle analysis. Some other time I can talk about it. When you use solar, from mining to use, you should find out how much energy has been used, how much pollution has occurred, how much water has been used, what is the cost, and what happens to the waste. When you put it all together, you get a sustainability index. All energy systems, without bias, without partiality, must be assessed on this basis. Life cycle, solar photovoltaic life cycle is 25 years. Coal is about 30 to 50 years, but we can make it 30 to 40 years. So this is one of my last thing. I will leave you with this. I have a final remarks at this end. I am talking about sustainability. So this is a question for you. I'm not going to give the answer. Instead of talking only about environmental sustainability, energy sustainability, food and blah, blah, why don't we talk about societal sustainability? The society must be sustainable, no? When all these requirements are there. So I want you to think about and define the above in your own way. Societal sustainability. What is an appropriate term for this in our Indian language? I want you to think about it. Don't just go by environment, economics and all. This is an umbrella kind of a thing, societal sustainability. You will be surprised what is the word I have in mind, but I want you to think about it. Those of you who want to respond to me at ajitkolar49@gmail.com. So my final remarks, a judicious mix of all energy resources is a must for India. I'm stressing all sources, including coal. Emphasis on indigenous technology development. Everything we have to import. We can't develop any technology. for all indigenous energy. Indigenous, I'm using indigenous sources, indigenous technology, indigenous financing, indigenous manpower, indigenous research. We are always dependent on others, even after 75 years of independence, so-called independence. So, including fossil, renewable, and new, like hydrogen and nuclear with thorium. LCA's life cycle assessment and sustainability analysis of energy system must be made. This is a very good BTech, MTech, PhD project. Kindly take different systems. One system you do for BTech, two systems for MTech, 3 or 4 systems for PhD. It's a wonderful area of research. And you will train students in that. Sustainable use of all energy resources with emphasis on energy security. Sustainable use I'm using, not energy resource. Sustainable use for energy security. The present RD&D community, like you, I am now, I'm now almost out of it, but I can give you this information. The present RD, research, development, and deployment community must act now to meet our national security needs to achieving true energy, electricity security. I mentioned this is my last mention. Energy scenario and sustainability are greatly influenced by geopolitics and not just based on science and technology, like you and I think. UN is only an advisory body. It does not have the power to enforce its sustainability agenda. Countries, economic and militarily powerful, dictate the terms. We, as Indians, we must act in our own national interest. Develop, please take this message to your student. Develop indigenous technologies for indigenous energy resources so that India will be energy secure. Or it will be energy insecure in the least way, because oil will still continue to import. But at least for electricity, renewable energy, coal and gas, and maybe future hydrogen. These are good areas for you to put your students on work and you to do your research. Thank you all very much. I thank Dr. Vasundhara and the team for giving me this opportunity on Teachers' Day. I have taken slightly extra time. I was supposed to finish at 7:15. I end here. Thank you. And any questions in the next few minutes, I'll be able to answer. Thank you all very much.
Thank you, sir. I request all the participants to kindly post your queries in the chat box so that sir can answer.
You can also ask orally, no problem. If they come online and orally, they can ask.
Yes, sir. You can unmute yourself and ask queries to the sir.
Hello.
Hello.
Sir. Hello, sir. Sir, thank you, sir. Thank you for wonderful presentation.
Thank you.
Thank you for bringing the geopolitical aspect into that climate energy and the sustainability issue. I have a very, I captured that you talked about the negative emission, that is capturing of carbon dioxide, right?
Yeah.
But how much actually, since you have all the numbers and research with you, like how much it costs per ton of capturing the carbon dioxide, and is it possible to capture carbon dioxide emissions from the vehicles and all? As per my knowledge, we can only establish the emission. I mean, whatever the power plants, we can pass through the emissions, certain solutions and capture. But is it possible to implement for the vehicles and all? So can you please shed some light on this?
It's a good question. The CO2 capture technology is not exactly in the nascent stages. There are several plants in the world which are using this technology to capture CO2. And unless it becomes really economically viable, like our hydrogen thing, it will take some more time for it to happen. But there is not in Andhra or Orissa, one steel company has put in this CO2 capture technology, only one in the country. So point number one, it is possible. Definitely today on small scale. This has to be scaled up and made economically viable. My point is, if we take that seriously, we can do it either on our own or with international help. Yes, it will cost money. Like hydrogen today is $5 per kg. Till it becomes $1 per kg, it will not be economically viable. Any new technology in the initial stages. So there's tremendous potential in that. Maybe we should get money from the oil countries so that they are also interested in continuing their oil sale. Now, second one is extremely important point. We have thought about it. Is there a possibility of fitting a carbon dioxide capture at the end of the tailpipe of the car? To be frank, because we have catalytic converters for nitric oxide.
Yes, sir.
But we do not have this. Whenever I have raised this question at our government level and others, they quote some kind of practical difficulties. No, this is not possible. And I really at this point in time cannot tell you what is the technical problem they have. My view is if we put our minds to it, especially our young engineers, they should be able to come out with a good capture system, a very small one for the automobiles. It has to be worked out how it can be done, how is it a disposable thing and all that. That's the answer I can give you now. Automobile industry is not doing anything about it. See, if the automobile industry comes out, you think they cannot come out with some technology? They can. But today they are pushing EVs.
Yes, sir.
So when the objectives change for the industry, they leave R&D behind for other things. They want to sell EV, which doesn't want CO2 capture at the end of the tailpipe. But they forget that today at least the electricity recharging for these EV batteries are coming from fossil fuel. At this point, I will say your question is very valid and it's very challenging. If some of you can look into it, it will be very nice. Thank you.
Thank you, sir.
Any other question, please?
Any other queries?
Some of you who are a little shy, you can write to me if you're interested and I'll reply to you. It's 7:30, so they're waiting for the next lecture. Go ahead.
Hello.
Yeah.
Hello, good evening, sir.
Yeah, go ahead.
Am I audible?
Yeah.
Yes,
Hello.
Anusha. Yes, Anusha.
Yeah, go ahead, Dr. Anusha.
Anusha, your voice is audible, Anusha.
Ma'am, it was not Anusha, actually somebody else who has a question.
Oh, okay.
Okay.
Dr. K. Srilata,
Hello.
please go ahead. You can ask the question.
Hello.
Yes, please. Hello.
Good evening, sir.
Good
I'm
evening.
Dr. Srilata.
Yes.
So I completed my PhD from JNTU Hyderabad.
Okay.
So during my tenure, apart from my PhD, I worked on gasification and also the pyrolysis unit.
Okay.
Using the garden waste and the vegetable waste, we have worked on that.
Fantastic.
So we got the biochar, the bio oil. So whatever the carbon dioxide capture, we said that using some adsorbent, we can capture the carbon dioxide. But the
Yeah.
thing is that first we have to know how much of the carbon dioxide we are getting. So I have tried with a Tedler bags. So I have captured the carbon dioxide, whatever we got from that emissions.
Very nice.
So with a GCMS, I have analyzed. So the
Okay.
thing is that I could not able to do the much of the carbon dioxide capturing things. But even I tried for the GHMC also for this proposal. For the still the second stage I went through that, but after that I didn't get any approval from GHMC.
Okay. Yeah,
So
this
that's a problem.
yeah, this happens in our research journey. But if you are really interested and you are a little passionate about it, please, you should continue because you've already done some initial
Yes,
work.
sir, I already done. Apart
Ah.
from my PhD work, I already done, and I have published a few papers also.
Yeah, okay.
So if you
Yeah,
don't
no,
mind, sir, can you keep your email into the WhatsApp group, sir, so that I will contact you.
Yeah, sure. AjitKolar14@gmail.com. See, this is the thing. When some good work is done and really required work, you need moral support and financial support to continue
Yes,
this research.
exactly, sir.
Unfortunately, India is only coming from the government, and government gives it according to their policies. Private industries, they should support these things, but as I said, they're a little reluctant. This is a difficult thing for technology development in universities.
Yeah, I went for 3 to 4 projects, sir, like funding agencies. But till the last one, I'm going, but I'm not getting any fund for this. So I have even planned, even fabricated the units for this to propose. Because if we go with a GHMC, because we can see the plenty of waste which is generated in Hyderabad and around the world.
Yes.
So if we get a chance to work on this will be a very good model and the societal problem which we can reduce.
Yeah. It is a double-edged thing. I wish you all the best, because we come up with these funding obstacles. You should please continue to try in whatever way that's possible.
Okay,
And
sir.
sometimes-
Thank you so much.
Please,
Yeah.
some of these, but sometimes you write to Dr. Saraswat, who is the energy chief in the planning commission in the Niti Aayog. He is from
Okay.
industry, he was a DRDO scientist. He's very much interested in biofuels and related things.
Yeah, yes, sir. Even I worked as a MNRE fellow, the Ministry of Renewable fellow as a JRF and SRF. But I
Okay.
was in the hydrogen production, say. So
Okay.
after finishing my PhD, I worked for this, but I applied for the funding. I didn't get no. So
No.
at presently, I'm working in a college.
Yeah, I know. Sometimes, please do write to Saraswat and ask him to help.
Okay. So if you don't mind, sir, kindly share your email address and the contact number, sir.
Thank you.
Thank you. Thank you so much, sir. And thank you for the organizers for giving me this time for me to ask the question. Thank you so much, ma'am.
Thank you.
Any more queries? Okay, I see no queries now. I would like to sincerely thank Sir for delivering such an enlightening and thought-provoking session. Your depth of knowledge drawn from decades of experience offered us not just information but insight into one of the most fundamental aspects of our everyday life. We appreciate your valuable time and patience for the session with us today. Thank you once again, sir, and happy Teachers' Day to you.
Thank you all very much. Happy Teachers' Day, and God bless you all.